Today our topic is calorimetry. Okay, calorie means heat, metry means measurement. So in this chapter basically we'll be learning something related with heat. Okay, so let us now understand what is heat. We have already done heat in class 7, 8, 9. Okay, it is just a revision for you all. Heat is a form of energy which flows from hot body to cold body. Okay, what is it? It is a form of energy. In which direction does it flow? It flows from hot body to cold body. Okay, now what are the units of heat? SI unit of heat is joule, CGS unit of heat is erg. There is one more unit called calorie. Okay, there is one more common unit of heat which is calorie. So let us define what is calorie. 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. There is a rise in temperature by 1 degree Celsius. There is rise in temperature by 1 degree Celsius or by 1 Kelvin, but we have to be specific with our answer while defining calorie. Okay, 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. If we raise the temperature of 1 gram of water from 10 degrees Celsius to 11 degrees Celsius, the heat is not 1 calorie. Okay, the temperature range has to be specific, that is from 14.5 degrees Celsius to 15.5 degrees Celsius. Alright. Now temperature, it is a thermal condition of a body, isn't it? Temperature is the thermal condition of a body which determines the hotness or coldness. If the body is hot, high temperature. If the body is cold, low temperature. As simple as that. Okay, but now we'll learn what are the factors, okay, that affects the quantity of heat absorbed by a body. Number 1, we have mass. Okay, more the mass, more will be the quantity of heat absorbed by a body. Number 2, we have increase in temperature. More the increase in temperature for a body, more will be the heat energy absorbed, isn't it? More the increase in temperature, more will be the heat energy absorbed. And last one, we have material. Different materials absorb different quantities of heat. For example, steel, to go from 2 degrees Celsius to 3 degrees Celsius, it may absorb different quantity of heat, whereas aluminium, to go from 2 degrees Celsius to 3 degrees Celsius, it may absorb different amount of heat. So there are 3 factors upon which quantity of heat absorbed by a body depends: mass, increase in temperature, and the material. Okay, so these all are the basics which we have already studied, so I'm not going in detail. Now our one of the important topic for class 10 is heat capacity or thermal capacity. Okay, so first let us go with the definition. Thermal capacity or heat capacity is the heat required to raise the temperature of a body by 1 degree Celsius or by 1 Kelvin. Okay, what is heat capacity? It is heat. Okay, what is thermal capacity? It is heat. So how much heat? That amount of heat, okay, which raises the temperature of a body by 1 degree Celsius or by 1 Kelvin. So suppose, let me write, we have a body, okay, whatever is the mass, we don't care about that right now. Suppose there is a body and its temperature is 2 degrees Celsius. Okay, and we give them certain amount of heat. If the temperature rises by 1 degree Celsius, that is it changes to 3 degrees Celsius, okay, then this amount of heat is called the heat capacity of that substance. Okay, whatever amount of heat energy I am giving to raise the temperature of this body by 1 degree Celsius, that amount of heat energy is called heat capacity or thermal capacity. Alright, so its symbol is C dash. Okay, the symbol for heat capacity is C dash and its formula is C dash equals to amount of heat divided by rise in temperature. C dash equals to amount of heat by rise in temperature. So in numerical form it will be not numerical, but its expression will be C dash equals to Q by change in temperature. This thing out here, delta, it represents small change in temperature. Okay, small change in temperature. So C dash equals to amount of heat by small change in temperature. Okay, now we will learn unit of heat capacity or thermal capacity. What is the unit of heat capacity or thermal capacity? So before doing the unit, first of all, look at the formula. What is the formula? C dash equals to Q by change in temperature. So if I have to write down the unit of Q, heat is joule, unit of temperature is degree Celsius or Kelvin. So the unit will become joule per degree Celsius or joule per Kelvin, or per degree Celsius or per Kelvin. Okay, it can have any combination, you can write anything. So I've given few examples. Okay, so few units I've given out here. Joule per Kelvin. Okay, let me show one more time. This is heat, change in temperature, joule per Kelvin, joule per degree Celsius, arc per degree Celsius, arc per Kelvin, calorie per degree Celsius, calorie per Kelvin. Okay, you can write any unit. If they have not asked about specific, okay, if they just ask you write down the unit, you can write any one of them. Okay, now next is our specific heat capacity. Okay, first one was heat capacity, this one is specific heat capacity. If there is word specific, okay, if you find the word specific, it has to be something related to one or unit. Okay, if you hear this word specific, it has to be related with unit or 1 kg, 1 gram, 1 centimeter, 1 meter, like that. Okay, so let us first see the definition. It is the amount of heat energy required to raise the temperature of unit mass of a substance by 1 degree Celsius. Now how much is the mass? Unit mass. Okay, how much is the mass? Unit mass. Unit mass means one mass. It can be 1 gram, it can be 1 kg, like that. Okay, so suppose I have a substance, okay, with mass 1 kg. Amount of heat energy required to raise its temperature by 1 degree Celsius is called specific heat capacity of that substance. Okay, alright. Formula: specific heat capacity equals to amount of heat divided by mass into small change in temperature. Its symbol is C, therefore C equals to Q by M into change in temperature. Now we have one more definition. There is alternate definition for specific heat capacity. It is the heat capacity per unit mass. Specific heat capacity is heat capacity per unit mass. Unit, see, per unit, that's why it is specific, per unit. See, specific heat capacity equals to heat capacity per unit mass. Okay, very simple. Therefore C dash will become C into M. Therefore C dash equals to C into M. This is the relation between heat capacity and specific heat capacity. Heat capacity equals to mass into specific heat capacity. This is one probable question for you all, so I want you all to remember this properly. Okay, so okay, unit. So before explaining unit, let me write Q by M into change in temperature. This is joule per kg per degree Celsius, joule per gram per degree Celsius, or per gram per degree Celsius, calorie per kg per Kelvin. You can write any unit. Okay, I have given few samples out there, so you can make your own units from here. I have given few units out there: joule per kg per Kelvin, calorie per gram per Kelvin, you can write erg per gram per degree Celsius, erg per gram per Kelvin. Okay, so you just have to look at the expression and the unit will follow. Alright, so this is the first part of our chapter calorimetry. Okay, and there is a numerical related with this chapter. Okay, so that for the numerical portion I'll be posting separate video. Okay, not with this section. For numerical I'll be making a separate video. Till then, let us continue with the chapter. Okay, now next we have calorimeter. Calorie means heat, meter means measurement, so it has something to do with the measurement of heat. Okay, now definition is given. It is a vessel which is used to measure the heat lost or heat gained by a body when mixed with one another. Okay, now what does it mean? Suppose there are two bodies with different amount of heat, and if they are mixed, the cold body will gain the heat energy and the hot body will lose the heat energy. So how much heat energy is gained by cold body or how much heat energy is lost by hot body is measured by this device or this vessel called calorimeter. It is basically a vessel. Okay, calorimeter is basically a vessel covered by wool, wooden jacket, etc. to insulate it. Okay, so that heat from outside does not enter the mixer and the heat of the mixer does not escape outside. Okay, now that's why the question may come, why there is wooden box or why it is covered by the wooden jacket, why there is wool. If this kind of questions come, you have to say so that the heat energy from outside does not enter the mixer or the heat energy of the mixer does not escape outside. Okay, and if you check this calorimeter properly, it is made up of a copper vessel. See, the vessel is made up of copper. There is thermometer also. So vessel is made up of copper, and the question comes. The question will be like this: why copper is used in calorimeter? Your answer will be because it is a good conductor of heat. Okay, it is a good conductor of heat, and it has very low specific heat capacity. Okay, because of these two reasons, copper is used in calorimeter. Okay. Now, principle of calorimetry. As I have already discussed, when the two bodies are mixed, one body will lose heat energy and another one will gain the heat energy. Okay, so the principle of calorimetry states, for a mixture of bodies, when there is no heat loss, see, in this case there is no heat loss, in this case, in this calorimeter, it is insulated properly so that there is no heat loss. Okay, so our condition will be, when there is no heat loss, the heat gained by a cold body is equal to the heat lost by hot body. This is the principle of calorimetry. Heat lost by one body is equal to heat gained by another one. So heat lost equals to heat gained. So this calorimeter is what we call one of the easiest section, okay, of this chapter. So it would be better if you all study this section properly, and you can expect question from this section also. Okay, now states of matter. I think I don't have to go through this properly because you already know what are the states of matter. There are three states of matter: solid, liquid and gas. Solid to liquid. Okay, if the body is heated, it changes from solid to liquid. It is called melting. If the substance is freezed, okay, if the heat is taken from the body, liquid changes into solid, it is called freezing or solidification. If liquid changes into gas, boiling or vaporization. If gas changes into liquid, it is called condensation. Okay, if substance changes directly from solid to gas, sublimation. If the substance changes directly from gas to solid, solidification, as in case of naphthalene ball, iodine. Okay, so sublimation, dry ice. So this is about the different states of matter. Okay, now without wasting any moment, okay, I have directly come to this numerical, not numerical exactly, but this question. Okay, let me first read out the question. A slab of ice at 0 degrees Celsius is constantly heated till steam is formed at 100 degrees Celsius. Draw a graph showing the change in temperature with time. Label the various parts of the graph properly. Okay, so first of all, the question is, the slab of ice is at 0 degrees Celsius. So where is my 0 degrees Celsius? Here, out at 0 degrees Celsius, and the water is boiling at 100 degrees Celsius. So this is my 100 degrees Celsius. This is my 0 degree Celsius. Here we have plotted time. Here we have plotted increase in temperature. Okay, so the question says, a slab of ice at 0 degrees Celsius is constantly heated till steam is formed at 100 degrees Celsius. Okay, now I am going to explain this curve. Now what is happening out here is, this is 0 degrees Celsius, this is 100 degrees Celsius. Now see, the ice is at 0 degrees Celsius and it starts melting. Okay, but this is the increase in time, this is increase in temperature. See, time is increasing but the temperature has not increased till here. The temperature has not increased till here. What is the reason why temperature has not increased till here? Because suppose this is the lump of ice. Okay, suppose this is the lump of ice at 0 degrees Celsius. Until and unless all the ice melts, the temperature will be 0 degrees Celsius. Okay, temperature will not change. This is called latent heat. Okay, the amount of heat energy used out here is called latent heat. Suppose we have a lump of ice at 0 degrees Celsius, and if we start heating, okay, when I start heating the lump of ice at 0 degrees Celsius, it will not immediately change into ice at 1 degree Celsius. Until and unless all the ice is melted, the temperature will not change. So when the ice is melted, first it will become water at 0 degrees Celsius, then only the temperature will start rising. I hope I am making it clear. So that's why, since there is increase in time but there is no increase in temperature, so at this point all the ice is melted. Okay, till this point there is a melting of ice, and at this point all the ice is melted. That's why from here the temperature starts rising. Okay, so now this is 100 degrees Celsius. Now after the ice reaches 100 degrees Celsius, water starts boiling. Okay, not ice, but when the water reaches 100 degrees Celsius, it starts boiling. Now again there is no change in temperature. See, it will stop at 100 degrees Celsius. So when the water starts boiling, it boils at constant temperature called, okay, it is 100 degree Celsius. So when we boil, no matter how much time we use in boiling, the temperature will not change, not increase. So the temperature of boiling water is 100 degree Celsius. So if you have not understood this particular problem, one more problem I have given here. Okay, so the question will be, what does AB represent? Okay, before doing what is AB, I'll explain you what is this curve all about. Okay, so as you can see, there is time plotted in x-axis, along x-axis, temperature plotted along y-axis. Minus 10, here the temperature is minus 10, here the temperature is 100. Okay, so the first temperature is minus 10. So I have ice at minus 10 degrees Celsius. Okay, and the time is given in x-axis, so the time is increasing. Till this time, ice at minus 10 degrees Celsius becomes ice at 0 degrees Celsius. See, now ice has reached 0 degrees Celsius out here. Okay, so from minus 10, ice has reached 0 degrees Celsius. Again after 0 degrees Celsius, this is straight. What does it indicate? It indicates the temperature is not increasing because ice is melting at this point. Okay, so within this point ice is melting. That's why there is no change in temperature. So when the ice reaches B, all the ice will be melted. By the time it reaches B, all the ice is melted. Now there is increase in temperature. See, the temperature is increasing until it reaches 100 degrees Celsius. As soon as the water reaches 100 degrees Celsius, it starts boiling and the temperature does not increase. That's why there is a straight line out here. Okay, so this is our heating curve. Now what does AB represent? AB represents melting of ice. Okay, what does CD represents? CD represents boiling of water. So what conclusion did you get from this curve? The conclusion which I can draw from this curve is, this is the answer. Okay, first let me show you the answer for 2. Okay, now the answer for question number 3 will be, here the ice is at minus 10 degrees Celsius, and with the increase in time, ice starts, it does not melt, but its temperature starts increasing, and when the ice reaches 0 degrees Celsius at A, it starts melting. Okay, and ice melts till it reaches B. So at B, ice is completely melted and the water increases, rising its temperature. Okay, the temperature of the water starts rising, and by the time water reaches C, it starts boiling at 100 degrees Celsius, and from C the temperature remains constant, that is 100 degrees Celsius, because the water is boiling at this point. Okay, so I hope you have understood till now. So please go through these topics again and again. If you have any confusion, you can write down in the comment.